بسم الله الرحمن الرحيم. أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضيات لغات، أهلا بكم. اليوم إن شاء الله سنتطرق إلى درس جديد في مادة الاستاتيكا، وهو عنوان اسمه مسائل على العزوم. Welcome my dear student in our math program for secondary 3. Today we are taking new lesson. It's titled Problems about Moments. Dear student, what is the moment? Moment is the product of position vector r cross f. F is the force which acts at a point, and we know that the moment may be equal 0, may be equal positive, may be equal negative. And the last period, we know that the moment, if the moment of B equal moment of C, what you deduce? We deduce that the line of the action of the force parallel to BC. But if the moment of V equal negative moment of C, we know that the line of the action of the force bisect BC. My dear student, look at the first example. Look at, my dear student, example. A, B, C, D, H are 5 points. A, B, C, D, and H are 5 points on a straight line, such that AB equal 4 centimeter, BC 6 centimeter, CD 2 centimeters, and DH equal 3 centimeter. The parallel forces 30, 25, 40 Newton act at points A, C, H respectively in the same direction, perpendicular to AH. The two forces 50, 20 newtons act at B and D points perpendicular to AH and in opposite direction to the three other forces. What is required? Find algebraic sum of moments of these forces about each of A, C, and H. My dear student, look at the solution. My dear student, look at the force 40 act at A, the force 50 act at B, the force 25 act at C, the force 20 act at D, the force 40 act at H. My dear student, moment about A. Its symbol MA equals length or the force of the length. Length of perpendicular 30 times 0 plus 25 times 10 plus 40 times 15 negative 50 times 4 negative 20 times 12 equals 420 Newton centimeter. Remember, my dear student, units of moment equals units of force times unit of the distance centimeter. My dear student, we know that if the moment in direction clockwise is negative, but if the moment in direction anti-clockwise is positive. Thus, we write negative 50 times 4, negative 20 times 12. Why? Because the force 50 and the force 20 act at 2 points with clockwise, but 3 forces 30, 25, 40 act anti-clockwise direction. Then we have 3 forces act at 3 points in anti-clockwise, but we have 2 forces 50 and 20 act at 2 points but in clockwise direction. My dear student, moment about C by the same point or by the same method, negative 30 times 10 plus 50 times 6 plus 50 times 0, negative 20 times 2 plus 40 times 5 equals 160 Newton centimeter. Also, moment about H, MH, its symbol, MH equals negative 30 times 15 plus 50 times 11, negative 25 times 5 plus 20 times 3 plus 40 times 0, answer is 35 Newton centimeter. My dear student, look at another example. ABC is a right angle triangle at B, where AB equals 6 centimeter, measure angle C equals 30 degrees. The force F acts in the plane of the triangle if the moment of F about B is equals 42 square root 21 Newton centimeter. Look at, my dear student. We say again, we have ABC is a right angle triangle at B, where AB equals 6 centimeter and the measure C equals 30 degrees. If we have force F act in the plane of triangle, if the moment of the F about B is equal to what? 42 square root 21 Newton centimeter. And the moment of the F about C is 42 square root 21 Newton centimeter, and its moment about F vanished. Then find F and the direction of each line of the action. My dear student, look at the solution. Look at MA equals 0. Why? The line of the action of F passing through A. We know that moment at A equals 0. Therefore, the line of the action of F passing through A. If the line of action of F passing through any point, then moment about this point vanished or equals 0. Therefore, we deduce that MB or moment about B equal negative moment about C. The line of the action of F bisect BC. Why? Because moment of V equal negative moment of C. Then the line of the action of F passing through D. This is number 2. The line of the action of F is positive. We deduce from 1, 2, and 3, AD straight line is the line of the action of the force F. BC equals 6 root 3 centimeter, BD 3 root 3 centimeter. AD square root 6 root 3 power 2 plus 3 root 3 power 2 equal square root 36 plus 27 equal 3 root 7 centimeter. Then we deduce that AD length equal 3 root 7 centimeter. Therefore, BN equals 6 times 3 root 3 over 3 root 7 equals 6 over 7. Square root 21 centimeter. BN equals 6 over 7 square root 21 centimeter. The moment about B equals F times L. LBN 6 over 7 square root 21. We know that the moment at B equals 42 square root 21. Then find the value of the force F by using divided each term by 6 over 7 square root 21. Therefore, F equals 49 Newton. Then the force F equals 49 Newton. Now we are translate to another example. My dear student, ABCD is a rectangle in which AB equals 5 centimeter, BC equals 12 centimeter. We have forces, its magnitudes 8, 15, 17, 10, 26 Newton. We have 5 forces, 8, 15, 17, 10, 26 Newton. Act along BA direction, BC, CD, DA, and CA respectively. What do you mean respectively? 8 act on BA direction, 15 on BC direction, 17 in CD direction, 10 DA direction, 26 at CA direction. Then what is the required? Find number 1, point H belongs to AB such that the algebraic moment about H equals 317 Newton centimeter. In ABC direction. Number 2, a point O belongs to BC such that the algebraic sum of moments about O equals 116 Newton centimeter. In DCBA direction. AC, remember, square root 25 plus 144 equals 13 centimeter. Look at solution. My dear student, we have ABCD is a rectangle. 8, its length. Look at, my dear student, the forces 8, 15, 17, 10, and 26. Look at M belongs to AC, H belongs to AB. Also, N belongs to AC. We have 5 forces, 8, 15, 17, and 26. Number 1, sum of moment about H equals what? Moment about H equal negative 317 Newton centimeter clockwise in direction. Let or suppose AH equal x centimeter. Draw HM perpendicular to AC. Then HM equals AH sine angle BAC. By substitution about AH equal x, sine BAC opposite over hypotenuse BC over AC equals 12 over 13x centimeter. Look at the moment negative 15 times 5 minus x, negative 17 times 12, negative 10x, negative 24x, negative 2 times 12 over 13, x equal negative 317, this moment about H. My dear student, we have 5 forces, negative 15, negative 17, negative 10x, negative 10, negative 24, negative 2. In direction clockwise, forces 15, 17, 10, 24, 2 in direction clockwise. So that we use negative sign. Negative 15 times length of perpendicular 5 minus x. Negative 17 times 12. Negative 10 times x. Negative 24 times x. Negative 2 times 12 over 13x. All or sum of moments equals negative 317. By solving this equation, left hand side, right hand side, and to find the value of x. My dear student, but 19x equal 38, then the value of x equals 2 centimeter. This is the value of x. Therefore, AH equals 2. Why? Because we suppose or we let before that AH equals x. After that, we find the value of x by using the moments, sum of moments about h, x equals 2. Thus, we deduce that AH equals 2 centimeter. Number 2, let CO equals y centimeter. Therefore, PO 12 minus y. Sum of moment about O It's simple. Moment O equals 116 Newton centimeter from the given. Therefore, my dear student, find or we substitution about sum of moment about point O. 8 times bracket contains 12 minus y minus 17 times y negative 10 times 5 negative 26 times 5 over 13 y equals what? 116 from the given. By the same method, we find the value of y. Therefore, we have 35y equals negative 70. Then y equals what? Negative 2. What you deduce, my dear student? O lies on BC ray or A. O doesn't belong to BC line segment. Then O lies on BC ray. Therefore, CO 2 centimeter. Remember, my dear student, length of any side not equal negative. Why? Because this length or distance, this real number positive belongs to Z positive. Therefore, CO equals 2 centimeter. Remember, my dear student, in distance more than 0 or the positive number. CO equal 2 centimeter. What do you mean? From the previous CO equal negative 2. Negative 2 means O doesn't belong to BC line segment, but O belongs to BC array. Therefore, O outside BC, CO equals 2 centimeter. My dear student, look at another example. The force F equals 8I plus 6J. We know that we can put the force by using I and J. What is I? The unit vector in x-axis, J unit vector in y-axis. I equals unit vector 1, 0, J vector equals 0, 1. We can write F equals ordered pair 8 and 6, or 8I plus 6J, fundamental vector. We deduce that, or we study fundamental vector in first secondary. We can put the force at 8I plus 6J, or ordered pair 8 and 6. The force F act at point A, 1, negative 1. Using moments, proves that the line of action of the force F passing through the point B, negative 3, 2. My dear student, what do you mean? The line of the action of the F passing through the point B, negative 3, 2. My dear student, in this example, the required proves that the force of F, or the moment of the F, or the action of the line of the force passing through the point. When the moment at the point equals 0, then we deduce that the line of the action of the force passing through the point. Remember, my dear student, if the required proves that the line of the action of the force passing through the point, we must prove that moment about this point equals what? Excellent student, equals 0. Then we deduce the line of the action passing through this point. My dear student, look at solution. Look at, my dear student, position vector R equals BA, A minus B, this point A minus point B. Point A minus point B equals 4, negative 3 ordered pair, or 4I minus 3J. We put are vector, position vector, or be a vector, A point minus B point for -3. We can put for -3 as fundamental vector for I -3j. These are. Moment about B equals R cross F. R, this rule. The moment about any point equal its position vector cross F vector. Or this is meaning of cross multiplication of the two vectors are vector cross F vector. Look at, my dear student, we have our vector for -3, F vector, or the force 8, -6. We multiply 4 times -6, -24, minus -3 times 8 equal +24, in direction K vector equals 0 vector. What you deduce? Excellent student. The line of the force F passing through the point B, line of the action of the force F passing through the point. My dear student, now we are translate to another example. FA 0.6 -9, B1 3, and C4 -1, and the force F1 of magnitude 9 Newton act at AB direction, and the force F2 of magnitude 5 Newton acts of BC direction. If I and J are the two units vectors in direction OX ray and OY ray respectively, and the unit of the distance in measure in centimeter, find number 1 F1 and F2. Number 2, find the moment of each of F1 and F2 about the origin point. The moment of each of F1 and F2 about the origin point, and then deduce the moment of the resultant about the origin point. Number 3, find the length of perpendicular from the origin point to the line of the action of resultant. Look at the solution. My dear student, F1 acts at AB direction. Then the line of F1 parallel to AB ray. Therefore, from properties of the vector, F1 equals KB vector. From the first secondary, we deduce that if F1 parallel to AB, we can put F1 equal constant times AB vector. If we have two vectors are parallel, we deduce that the first vector equals K second multiply second vector. K is real number not equal 0. Look at, my dear student, AB vector equal B minus A point. We have -5, 12, this AB vector. Norm AB vector, what is the meaning of norm? Length of AB vector, square root -5 squared plus 12 squared equals square root 25 plus 144 equals 13. Then F1 equals 3 AB, F1 equals 3 times -5 and 12, F1 -15 and 36. F2 act at BC. Then the line of F2 parallel to BC by the same method, F2 equal KBC vector. BC vector equals C minus B. We subtract first component and second component. Answer is 3, -4. What is the norm of BC? Square root 9 plus 16 equals 5. Square root 9 plus 16 equals square root 25 equals 5. This is the norm of BC or length of BC. Therefore, F2 7 BC, F2 equals 21, negative 28. My dear student, by the end of the lesson, I am very happy to spend such time with you. Thank you. Goodbye.